Good afternoon, everyone. I'm Dr. Tony Lang. I'm the director of the Movement Disorders Clinic here, and I'd like to welcome all of you to what I think, Steph, is maybe our fifth? Sixth. Oh, I've lost track. This is our sixth session of Movement Disorder Speaker Series, and the purpose of this series is really to inform, to bring you up to date as to what's happening in our program. For the first attendees, this is a series that is chaired by me to begin with, but I'm going to apologize immediately and tell all of you that I have a flight to catch, so I'm going to leave. And with any luck, my assistant director of our unit, our co-director of our unit, Dr. Susan Fox, will come down at the end and will chair the question and answers, and thank you for attending. So, this is typically a session that is given by one or two of our faculty. So in the 5 previous sessions, we've covered quite a lot of material from just what's happening in Parkinson's disease and movement disorders, what's happening in the research that goes on in our unit. We've covered the surgical program, we've covered some of the electrophysiology, and we try to combine the session with a lecture from one of our faculty and then some presentation by someone in the community, somebody special to the program, somebody who's contributed a great deal to the work of Parkinson's disease. And in fact, today we have a couple of speakers that fulfill those 2 criteria. I'd first like to thank our foundation, Steph, Elizabeth, and now Catherine Wallace, who are helping us run these sessions, and then particularly Fraser Barrell, who's been very supportive of our program and has helped support today's event. Thank you very much. We put these on, as I told you, to inform, but also to thank the members of our clinic who donate to our program. We really can't do what we do without philanthropy, and this is a very good example. We have to rent this hall to run this session, so we're very grateful to all of the support that you in the audience and others like you have given to our program. So today, you're going to have a special treat because you're going to see a lot of incredible images, and Dr. Strafella, his family's here because they think that he works at a computer and doesn't do anything else. He just sits there and types on keys, but I think he does a lot more than that, or at least that's what he tells me. Dr. Antonio Strafella is a full professor in our program. He's a movement disorders neurologist and a neuroimager. He wears a special hat in his ability to understand the imaging of the brain. I've known him for quite a while. We go back to when he was doing electrophysiology here under Dr. Peter Ashby, and then he went back to Italy, and then he went to Montreal, and I remember sitting in the back of a cab with him once when I visited Montreal. I said, Antonio, is there any way I can get you to come back to Toronto? And fortunately, his mother-in-law lives in Toronto, and so that was a little bit helpful to bring him back, but I think he came back because of the academic draw. I don't think his wife agrees with me entirely on that one. So Dr. Strafella is really a world-renowned neuroimager. He does imaging of the brain using multiple different formats that he's going to tell you about. And he is really one of the leaders in the field of looking at brain function in Parkinson's disease and related disorders using quite a variety of imaging tools. And so he's the guy that costs a lot of money because these imaging tools really are very expensive, but you'll see why, because they really provide us tremendous insight into how the brain functions normally and how it functions abnormally when we have diseases, when we have treatments for those diseases, and so Antonio is really going to educate all of us today. So again, welcome to the session. Thank you for your support. Thank you, Mr. Barrell, for your support, and Antonio, take it away. Dr. Strafella will chair the questions and answers at the end. And I guess maybe what I should say before I leave the podium is that our second speaker is Elinor Johnstone. And I think, Antonio, you're going to introduce Mrs. Johnstone, so I think I'll say no more, but we're all excited by having the combination of these presentations this afternoon. Take it away. Thank you very much.
So thank you, Tony, for the kind introduction. Very kind, of course. And so, as you heard, most of my work is done with imaging, taking pictures of your brain, and trying to understand how Parkinson, let's say, works. And it's a very complicated field because sometimes dealing with the symptoms, we don't really know what those symptoms are creating or changing our brain, okay? So, of course, probably I should not give you any introduction about this because most of you probably are well aware of these symptoms of Parkinson's disease. So, of course, everybody associates Parkinson with tremor, associates with Parkinson with rigidity and bradykinesia. But as you know, sometimes you also have a number of non-motor features like sometimes some memory problems, sometimes some hallucinations, sometimes, of course, you can have a constipation, feeling dizzy. So a number of non-motor features that are very difficult to explain sometimes, and unfortunately, we do not have many treatments. And that's why we try to do this research in order to understand how these symptoms are associated with changes in the brain. Okay, so and of course at the end you can also ask me some questions if you have a particular things that you would like to ask. And so, very simple. When it comes to the brain, everything is complicated. Nothing is easy. Okay, in our brain we have different parts that are linked to different functions. Okay, so in red, for example, that is called the prefrontal cortex. Is generally very important for behavior, okay? And then we have the yellow part, we call the sensory motor part, is very important for the motor function, the sensory function. And in the back of the brain, the occipital cortex is very important for vision, okay? So you would not probably you're not aware of that Parkinson can affect all those areas over the course of the disease. So it's a very complicated disease. And so sometimes what we do, we ask our, of course, patients very kindly to participate in our research, and we try to take these sophisticated images of the brain, okay? And I have to say, sometimes it's not really easy because patients have to be still in the scanner. Some of them, of course, have claustrophobia, as you probably know, and so it's not an easy task. But at the end of the day, we're able to have these fancy pictures where we see all these connections in the brain going to different parts of the brain, okay, from the front to the back. And so we use this with different colors in order to enhance the changes, okay? And this is just an example of what we can see in terms of synaptic changes, in terms of that we can measure, for example, dopamine in the brain. You know that dopamine is very important for Parkinson, right? So that is actually the chemical that make us to move around, also to think, and also very important for reward, okay? Every time you get a reward, any type of reward, the dopamine is very important, okay? And reward and motor system, they actually very much interconnected with each other. So, for example, if I ask one of you to stay in the scanner, this is actually the brain of one of you here, and you can see that you have all these changes. You are at rest, you are not doing anything, you are completely relaxed, but your brain is actually changing. You see how that the yellow color is moving around, okay? So even though you're not really doing any action, actually probably with eyes closed, your brain is very active, okay? And to quantify these changes, it's not very easy, it's very complicated, because what we do sometimes is, you see, we try, actually, that's where our statistics and mathematics comes into it. So we try to decompose the image, the signal, into several dots in order to make some measurements that we can quantify with a number, okay? So you see on the bottom, for example, that diagram, that mosaic, okay, that allows us to give us a number to the different parts of the brain, okay? So this is very, let's say, a long process, like usually you have to stay in the scanner like half an hour, sometimes even 2 hours in order to acquire all these informations. Okay, so it's a very complicated, and this is not what we call routine. This is research. Okay, so because we are trying to understand how the brain works, and that's the most important part of this presentation. So you see on one side of the slide, you see the synapse. So really, when we go into detail, our brain is made of little connections, okay, with molecules that are going from one contact to the other. Without that molecules, we were not able to move, to think, to do anything, absolutely. That's dopamine, for example, for you. So then when we have that connections with those changes in dopamine, then we're able to have those maps, those that with different colors, in red and blue, that is telling me that certain parts of the brain are red, which means are active. Certain parts of the brain are blue, means that not active, they're actually silent, okay? So that's actually your brain at rest when you don't do anything, okay? And then by measuring all these changes in the brain, we are able to investigate the behavior of the brain, okay? So this is our approach to study these symptoms. So let's imagine, for example, that we have these fancy tracers, okay? And so on the top you see that rectangle, right? The rectangle is the part of the brain that we're really, really interested when we have to study patients with Parkinson's disease, because we know that that part of the brain is called basoganglia, and that is really, really affected in Parkinson's disease. Then, of course, we get these fancy scans with different colors. You see on top, you see fluordopa, okay? And one side is a normal subject where you see the basoganglia that are fully activated, okay? So you see the red, you see the yellow, you see the white, means that that's a normal scan, okay? And then on the side you see a scan with Parkinson's disease. It's obvious to you, right? It doesn't take actually any measurement. It's just visual that there is a difference between the normal subjects and the patients with Parkinson's disease. You see a significant, we call, degeneration of cells. So there is not much red anymore, there is not much yellow anymore, it's just a little bit of blue. It means that there is not much dopamine left in the brain. Okay, and sometimes if you look on the bottom of the figure with what is called the VMAT2, in the side where it's Parkinson's disease, you can see also a certain type of asymmetry between left and right, right? One side seems to be more affected than the other, so that's why you have one side of the body that is having symptoms and the other side is less affected. So in our patients, we always see this asymmetry between the left side and the right side that you can actually measure when you take these fancy pictures, okay? So usually to do these studies is, again, very complicated because the patient needs to stay in the scanner up to 2 hours, sometimes stay still and off medication. You can imagine all kinds of problems, right? So it's not an easy task. And so sometimes one of the major problems that we have in our patients is the cognitive aspect, right? Certain patients say, oh, my memory is failing, I start forgetting things, and I plan something during the day and then I forget, okay? So if we try to take a picture of a brain that is having these type of problems, then we see different changes, okay? This is actually a series of images that taken with different approaches, okay? The names that you see there probably doesn't mean anything to you, but for us are very important. Because, for example, just one figure, where does it say amyloid? Amyloid is a very important protein in the brain, okay, that when it starts accumulating, then you can have a significant memory problems, okay? That patients sometimes with a significant dementia may have, okay? And also where you see ACHE, which is cholinergic system, there is a significant degeneration also of the cholinergic system. So it's not just about dopamine, it's also about other chemicals in the brain that are getting affected over time, okay? So it's, Parkinson's disease is a very, very complicated disease. It does not affect one part of the brain, affects many parts of the brain, and not just one chemical, but many chemicals, okay? So it's something that we learn over time. And so then we also, we have a patient that sometimes they say, oh, I'm having visual hallucinations, okay. Or sometimes they say, oh, I have also, I'm becoming less interest, having more apathy, less engaged in things. So these are neuropsychiatric complications, okay? So if we go and measure these changes in patients experiencing these symptoms, we see all kinds of different abnormalities, okay? So things are becoming more and more complicated for us because at the beginning, a few years ago, we always associated Parkinson just with the motor system, but now we are learning more and more that it's not just about the motor system, it's also about non-motor symptoms, which sometimes are very difficult to deal with because we don't have medications or treatments to deal with these problems, okay? And so another symptom that you probably heard, sometimes when you go in the clinic with our colleagues, they ask you, by chance, you know, this medication called dopamine agonist, right, Mirapex, Pramipexole, and others, that are you gambling by chance, or you having hypersexual behavior, or you have a compulsive shopping? And you say, no, I don't have any of those. But certain patients, sometimes 15% of those patients may have these type of problems, okay? It's called impulse control disorders. And so they start gambling, losing a huge amount of money. They start having compulsive behavior, like hypersexual behavior, compulsive shopping, binge eating, okay? And so when we start realizing this problem, let's say now 10 years ago, we didn't really know what was the main issue. And then, of course, we start imaging patients having this type of problem, and we noticed little changes in certain parts of the brain associated with reward, okay? So it's interesting to know that if we use this medication called dopamine agonist, we might stimulate certain parts of the brain associated with the reward. So somehow they want to gamble more patients. But again, it's not the majority, it's only 15% of these patients. So you wonder why this 15 behaves like this and the other do not care. So that has been a very interesting question or topic for us to explore because we didn't know much back then, but now we are very much aware of, and so we're always asking those kind of questions to our patients. And overall, I have to say, Parkinson, I would associate Parkinson with an iceberg. So what we know is really the tip of the iceberg, okay? And as every year, we are learning more and more what is not, let's say, above the level of the water. So it's always what is under the water that it's very the unknown for us. And sometimes we learn, of course, from the patients because they tell us symptoms that sometimes we're difficult to associate with Parkinson, but that's what we're learning. And so, and these images, of course, are helping us to understand Parkinson's disease. So it's a journey that started a number of years ago, and now, of course, we understand more of this problem. But I have to say there is still a long way to go. And in the next 10 years, I think there's going to be even more understanding of this Parkinson and what we call atypical Parkinsonisms, okay? So it's a huge umbrella that goes under the name of Parkinsonism. So this was just a little introduction for you to get an idea of how complex and complicated is the field. It's not easy for us to address all the problems. Sometimes when we hear certain symptoms, we always think if it is associated with the degeneration, the changes that are happening in the human brain. And of course, we have a number of fellows and students, graduate students, that help us to study the brain. And so all these people that working with us, they learn from us, but we also learn from them how to study the brain. And so at this point, I would like, of course, to acknowledge all my colleagues, because this is a teamwork. It's not that the work of one person. So everybody together here has a mission. The mission is to understand the brain and how this is associated with Parkinson's disease. And of course, all together we work in order to explore the brain. And so we have all the different funding agencies to help us to image the brain because it is a very complicated research. And so at this point, I think probably I should actually give you the thank you at the end of this. And, and I would like to introduce a patient of mine, Elinor Johnstone. And Eleanor has been with me for a number of years. I think I moved in Toronto in 2000, as you heard from Tony Lang, in 2006. And I think she became one of my patients early on in my, after I moved here to Toronto. I have followed her for now, of course, since then. And over the years, we meet every 6 months, as most of you. And we had a conversation about Parkinson, how things change. And of course, she's also a PhD, so she's a writer. She wrote a book on Ernest Hemingway, and she told me, "Oh, I wrote this book." I said, "Oh, perfect. Why then you don't write a book also on Parkinson's disease, since you like to write?" And then we started this journey writing this book, and of course she did all the work. I just read it, nothing else. So there was this opportunity for Eleanor to give to the audience here now her experience with Parkinson and also her experience in writing. So I would like to introduce Elinor Johnstone, and it's a pleasure of mine.
Good afternoon. I wrote this book, Shaking Parkinson's, to give myself and other Parkies hope in dealing with a disease that is quite a challenge, to say the least. As well, in telling my story, I would like to thank Dr. Strafella, along with all his staff, for their friendly expertise. So, for about 10 years, maybe more, I've lived in a peculiar time warp that is characterized by the fear that scientists will not discover the treatments I may well need in the next 10 years. Thanks to the many teaching hospitals such as this one, thanks to scientists, government donations, fundraisers, and celebrities, we have some hope. Hope for an example, a vaccine that would prevent Parkinson's and wipe it out, like polio, that was still a scourge in my childhood. I can still recall the jump of joy in the pit of my stomach when I heard a major scientific voice use the words, hope for a cure. Until just the recent past, we did not have that hope, but now we do. Let's look around and see how hope works. I remember one day at school, I was feeling down, lonely, not part of the in crowd of other teenagers. Looking around, I saw a girl called Susan standing by herself, staring unhappily at the others, thinking that she looked marginally more miserable than I felt. I went over and struck up a conversation. Within a minute, I felt a rush of happiness, and I could tell that both of us were starting to cheer up. I learned in that moment that we help ourselves by helping others. We are told that the first day a person endures having Parkinson's disease is the day of diagnosis. In that case, we have nowhere to go but up. We who suffer from Parkinson's are labeled in a whisper from the moment someone notices a tremor in one of our hands. From that point, we are treated with fascinated, unwanted pity. At lunch in a cafe, this is a true story, a granddaughter asked in her loud voice, "Nanny, why is your hand shaking?" After I had stumbled to answer, she pointed at my other hand. "Nana, why is your other hand not shaking?" There's nothing to do in situations like this except find a carpet to hide under. I tell myself that there are lots of other worse diseases, I persisted in living a normal and meaningful life in spite of bothersome symptoms. Dr. Strafella calls me the genius of denial. But then he had a truly great idea to help me deal with my worries. He suggested that since I had self-published 3 novels already, I should use the form of a novel to tell the story of a fictional middle-aged woman coming to terms with having Parkinson's. Perhaps this might make a research topic, study how the brain works when engaged in an interesting writing assignment. Is imaging creativity a medical topic? But I digress. Back to the novel written at the suggestion of the neurologist. I immediately and cheerfully went to work wondering about the characters. What would they do and say? Joyce Saunders would be my main character. Some might say my alter ego. I set about to use her fictional experience of Parkinson's to explore the effects of the diagnosis on others, especially spouses and children. Writing this novel forced me to face my denial and grapple with the symptoms of Parkinson's. Like the protagonist, I too worried about its impact on my marriage and my relationship with my children. We know that Parkinson's runs in some families. I grew up on a farm, and I wonder and worry about the link between Parkinson's disease and pesticides. I wonder why I have the disease and my brother and sister do not. At this point, I reminded myself that I was writing a creative fiction, not a memoir. And this gave me the ironic distance that I needed to deal objectively with the topic of coping with Joyce Saunders' diagnosis. Next, I turned to the wisdom of early feminist Canadian fiction. One basic question was, what is our response to fate? As Canadian pioneer Catherine Parr Traill put it, in cases of emergency, it is folly to fold one's hands and sit down to bewail in abject terror. It is better to be up and doing. This is a central theme my novel attempts to address. And so too, many of us here ask ourselves, how do we live with this disease? In my case, I choose to be active, to ride my bicycle and go swimming in nice weather, to walk a country mile or two in any weather, to do Pilates every week, to go to the fitness center as often as possible, to practice balance exercises, to take ballroom dance lessons with my husband, to work in our garden, to play with our grandchildren, and to write a novel. This creative response to my predicament. And was it ever fun to receive a phone call early last fall from Michael Terence Publishing, a company just south of Oxford in England. The publisher had heard about my book from a former colleague, another author. When the publisher heard that I had a polished style and that I was writing on a very timely topic, he wanted me to submit my yet as unfinished manuscript. Within a few days, he was sending me a contract. My fellow PhD in writing, my husband Wayne, joined me in writing, revising, structuring, restructuring until my book was finally complete. All our friends and even our children were impressed that I had an English publisher, an American printer, a Canadian courier, UPS, and a spot on the sales lists of both Amazon Kindle and paperback. There, Wayne and I were importing books at the Lewiston border. Good thing that the books arrived in time for us to use them as Christmas presents. Now, I would like to read some excerpts from my novel so you get a sense of who's who and some issues they face. I aimed for truth and accuracy in putting together a story with its own characters, conversations, thoughts, and emotions. My protagonist, Joyce, a music teacher and violinist, and her husband, Morton, a chemistry teacher and cellist, decided that what they needed was a March break vacation on a Caribbean island. Joyce was thinking, a skunky mood was having a detrimental effect on what was once a basically resilient and generally happy marriage. On the first day at the resort, Joyce and Morton set themselves up on the beach. She was trying to finish and send their family physician a personalized list of Parkinson's non-motor symptoms for him to distribute to new patients at his medical clinic back home. Morton was in a more self-interested mode, entertaining himself by acting like a waiter as he approached the beach bar. Joyce was going to yell after him to get himself a double, but noticed that no one else was yelling. When he returned, he said that the bar was open, but not ready for serious drinks, like the orange ones on the left-hand side of the menu. I thought I'd get us started with small beers and then proceed to the rum chasers. He handed her a small beaded glass of beer. Joyce squinted at him. It's kind of early for drinks, eh? We're Canadians, after all. I've no idea what time it is, he said. I didn't want to disturb the other guests who all seem very quiet. The laptop says 10:25 a.m. Well, that means it's 4 o'clock in Tuscany or somewhere. Joyce pretended to growl at him. Go get my feckless drink. The menu says that the bar opens at 10:30, so I think they should be ready to mix our orange drinks by now. Yes, ma'am. Time passed as Joyce and Morton attempted to articulate the symptoms their family doctor requested. Joyce reviewed what they had written. I'm guessing that the symptoms that I think are distinctive to my experience are actually familiar to other patients. I'd say that you're not ordinary in the least, and also that there's a good chance you do not have Parkinson's. He made a wry face and started typing. Joyce said, pitch. We're not talking baseball here, but music. When I was young and someone wanted the first note of a piece, I could hum it in perfect pitch. It was not just accurate. It was also tuned precisely, never wobbling in the space between two semitones. Is wobble an actual word? Yes, wobble is a lack of musical precision. To my horror and embarrassment, I am now usually a tone or semitone flat, unable to find the note, so I nod to the accompanist. This is one of the worst effects of Parkinson's for me as a singer. Even if I have a piano handy, I sound horrible. What are you going to do about it, he asked. I don't know, Joyce continued. Now, about doorways and boxing, there have been some intriguing media reports of late about Parkinson's patients who apparently pause and look around as they walk through a doorway, since doing so helps them remember both the room and the idea they are leaving. Don't you think, Morton could barely get a word in edgewise, exercise of many sorts is good for Parkies, especially boxing. Witness the example of Muhammad Ali. Joyce sighed, tired of hearing people go on about boxing. Okay, making mistakes, she said. Sometimes I'm sure of something, and people I trust say the opposite. I've learned to back off from my perception. In fact, I seem to be wrong more often than not. This is humiliating. I'm used to being right. Humility is essential, along with humor. So far, I have not been afflicted by such craziness when I've been teaching music theory or music history. They both stared out to the breakers at the mouth of the bay. Finally, Morton said what was on both their minds. losing it. Generally going crazy, she asked. He glanced at her face, then waited for her to continue. All these problems and quirks to deal with. Once your dear brother emailed me a list of typical Parkinson symptoms of cognitive issues. The file is there on my desktop. And he laughed, saying almost all adults demonstrate one or two on this list as part of growing old. Morton paused and started to speak, stopped and flicked small stones against the trunk of the palm tree they were under. So, I identified with all of them, she said slowly. Her voice sounded almost harsh, critical. Joyce told Morton, maybe you should open Gmail and attach this list to a message to the good doctor. No, let's not send it yet. Morton groaned. Are you still hoping that you can talk Dr. Ajax into persuading Sean to back off from his dangerous plan? Sean, their son, had been an idealist since childhood, an irritant to his pragmatic father. He had succeeded in completing his medical training despite his father. Now another problem was coming their way. Sean had emailed to express his frustration with the rising violence in Quebec against recent immigrants. He had admired the works of Médecins Sans Frontières, and now he was thinking of joining. Morton's tone grew more irritated. What a stupid adolescent thing to do. He downed his glass and spit out a mouthful of the drink. Does it occur to you, he demanded of Joyce, that our son is being radicalized? He's out of his tree. Morton had paced up and down the beach before he finally exploded. Is he dedicating his life to saving the world? Or is he simply planning to join the Doctors Without Borders people to get himself blown up? I thought they just sent us more and more huge maps, so we'll keep donating. Joyce had rarely seen him so distraught. For heaven's sakes, we've got to support our son. Are you implying that I've been neglecting my son's courage or brilliance or whatever? Just listen, Morton. This isn't about us. It's a big step he's thinking of taking, and he seems to understand the nuances and complexities involved. But why on earth would he get involved with an organization like that? It's not safe for him to leave the country. And just what is he planning to do? I don't think he knows what he's doing at all. Joyce felt frustrated. Why did Morton always seem to corner her into siding with others, not him? She tried reasoning. Are you yelling at me because I admire our son's courage? You don't know anything about the group he may join. Morton was still venting his anger. Nearby sunbathers sat up, irritated by his yelling, but he seemed not to notice their frustration with him. He tore off his shirt and kicked off his sandals. Joyce, watch our stuff. He stomped into the waves that had a strong undertow. Before long, he was up to his waist. Joyce stood up and looked around. The guards had taken their green flag down and were putting up the red one. Joyce saw Morton waving and shouting as he stumbled, battered about by the waves. The guards were yelling, and she saw two of them jumping into a motorboat. She imagined that the young men would be swearing, furious at having to risk their lives in the rising wind and waves. He dove in. That's where I'm going to stop reading. What happens? In summary, Shaking Parkinson's has all the pleasures of fiction: suspense, love and fury, character development, and clever dialogue. Feedback has been positive as readers realize that they are not alone in their everyday experiences. I hope that you, patients, family members, and medical staff, will see how patients can feel reason for hope. A diagnosis of Parkinson's disease need not terrify individuals or their loved ones, because we can, in a sense, shake it off. In the meantime, our purpose is to help our fellow creatures, and that involves being grateful for the important efforts of our research teams as they continue to fine-tune their treatments of Parkinson's disease while persisting in finding a cure. I'd like to end by saying again to Dr. Strafella, thank you for your wisdom, and to my husband, my best friend, thank you. Bye.
So I think we can now entertain some questions. So open to any type of questions. And
Are there things that we can do with patients to increase the production of dopamine outside of medicine, like listening to great orchestral music or something?
yes, I mean, remember that Parkinson is a degenerative disease, right? So because the brain or the cells are degenerating, so we are losing dopamine in the brain, along with other chemicals. But you can, let's say, either having exercise or engaging in intellectual activities, stimulate your brain, because of course the brain is very plastic, and somehow is able to compensate to a certain degree, to a certain level, for the lack of cells that we have in Parkinson's disease. So, of course, you're not going to be able to eliminate the problem, but at least you can try to compensate for the problem that has been created by the disease. So, definitely intellectual activity, listen music, stimulating your brain plus physical activities can help, and that's something we always suggest to all the patients, as long as there are no other contraindications to do exercise, for example. So definitely you should continue to do whatever you've been doing so far, because you're doing quite well. And also, ask also Eleanor with her experience. Yes?
My question is at the beginning of your... Thanks. At the beginning of your presentation, you said that it's difficult to get the results of the testing because putting a Parkinson's patient into a tube to lie still for such a long time is difficult, and to relax. Is there a difference in the results if the eyes are open or if the eyes are closed? Because
That's a very good question, technical question. Yes, they are. In the sense that when your eyes are open, okay, your brain receives a certain amount of stimuli that are different than when your eyes are closed. And also, when your eyes are closed, there is a tendency to relax more and to almost fall asleep. And so when you fall asleep, your brain changes. So that's why we always instruct patients, based on our question, we always ask the patient whether to keep the eyes open or keep the eyes closed, because we know that we might get changes in the brain based on that, just a sensory feedback. Yeah, even though it's a very simple thing to open and close your eyes, but the brain reacts very differently.
Doctor, can you explain impulse disorder, like the rewards, a little bit deeper?
Yes.
On other facets of how you change or the...
Yeah. So again, this is a very important question, because as I mentioned to you before, for us, when we start learning about these problems, it was about 10 years ago, a little bit more probably, and we know that when you use this medication that we've been using, of course, stimulates certain parts of the brain, okay? And we learned that certain parts of the brain degenerate more than other parts of the brain. And so, for a certain reason, for a reason that we still is very unknown, 15% of these patients start having this gambling behavior sometimes. So we start the medication, and then after 3-4 weeks, they start having some, they start gambling on the computer, or they just go to casinos and so. And then also other patients, they may have a hypersexual behavior, very sensitive matter, or they can have a compulsive shopping, start buying things that they don't really need. right? And also binge eating, like eating without any, let's say, stimulus of really that is needed. So we know that all these have as an underlying feature reward. Okay, so when you start gambling, when you start having hypersexual behavior, when you start having compulsive shopping, when you're having binge eating, you are stimulating the part of the brain that is associated with the reward system. Somehow you're trying to reward yourself, okay? Because somehow your brain is lacking of reward. And so this is something that it's very problematic because, of course, if you get into those problems, the only thing you have to do in these 15% of patients is try to stop the medication or try to reduce the amount of medication. But, of course, the problem is that first, a number of patients do not like to stop the medication because, of course, the motor symptoms can get worse. And so that's a very tricky topic to address because they say, okay, definitely I will stop gambling, but then I won't be able to move, right? So then you have to find the right balance. So that's a very difficult thing to address with the family because it's a family problem. It's not just the patient problem.
Besides the shopping, the sexual, and is there any other facets?
Yeah, they can be others as well. More, let's say, these are the majority. Okay, but sometimes patients can have other forms of addiction. We call behavioral addictions. It can be as many as you like. Okay, now certain people sometimes they can also have what we call panding. They start doing things over and over again. It's like these compulsive behaviors. Okay, and that's a very complicated thing because they just keep doing the same thing over and over again. So other people, of course, they can have other minor behavioral addictions. So like there is another form, it's called the dopamine dysregulation syndrome, where patients also may have keep taking medications without really needed sometimes. They just keep using it because they feel the need, the urge that they have to take more and more medication, and that's called dopamine dysregulation, which is another behavioral complication. So there are different facets of this, and it's very sometimes complicated to dissect all these aspects, yes. Yeah.
Thank you for your presentation. It was most interesting. I know that Parkinson is a neurological disease. Does it have influence on Crohn's disease or colitis or vice versa?
Yeah. So that's a very good question. So it's not that we have a clear association with Crohn and colitis in general, but we know, for example, that I can tell you that we know that Parkinson sometimes is associated with severe constipation. Okay, so this problem, believe it or not, can be present even before the motor symptoms start. Okay, severe constipation. And if I have to really push your question, there are colleagues around the world that they believe that Parkinson starts in the guts, in the colon. Okay, so this is an idea that has been floating around now for the past few years. With somehow there is deposition of proteins we call alpha-synuclein in the colon, and then somehow it gets to the brain. So this is something that has been floating around now for a few years, and we still don't know if that is true or not. But definitely we know that there is some kind of changes happening also in the colon, in the gut, but also in other parts of the body, like the heart, the skin sometimes. So it's a very multisystemic disease. So this is, again, this iceberg that you showed before, it's what we feel as a motor symptoms. The brain is just the tip, but then it is everything else that we don't know.
Two questions, but they're, thank you.
You can also Eleanor, right?
But they're related. Your therapy, your diagnostic tools, are they used at all to assess the effectiveness of new drug therapies?
Right.
For example, repurposed drugs, that kind of thing.
Wow, that's a very good question. So we would love to, but still there is, because these treatments, these scans deals with nuclear medicine, okay, with radioactive material. So this is a very sensitive topic when it comes to the government, okay. So this has been used so far mostly for cancer, So actually, this type of scans generally is very much well known in the field of oncology because with cancer patients have been using this for a number of years. But now, in the last probably we'll say 10 years, we have been using more and more for the brain. But this is at the moment just for research and not for clinical daily use because they are very expensive. And before you start using, let's say, on everybody, the government wants to make sure that you don't spend too much money because they're very expensive. So it's a very sensitive topic at the moment. Now we know that a scan that was, for example, available in the US is called the DAT scan, is one of those I show you, will be available eventually in Canada, so eventually. So we'll see how things slowly are moving also for making changes with the government. But again, if you have an influence on the government, then you should try.
You said that the impulsive disorders were related to dopamine agonists.
Yeah.
And if I understand it, dopamine agonists are different from the levodopa-based
Correct.
drugs.
Correct.
So if they have that problem, why is it that people don't just change to the levodopa-based drugs?
Very good question. Yes. See, this is a treatment approach. So, as I told you, we learn along the way, right? So, as you know, levodopa, of course, levodopa has been around now for several years, right? Decades. And of course, as you know, initially, we learned that as you use more and more levodopa, you get this, what we call motor fluctuations, or levodopa-induced dyskinesias, right? Where you start having these rocky movements. And so, of course, a couple of decades ago, people start saying, okay, why we don't try to find something else that maybe reduce the amount of these dyskinesias, right? So patients do not have these problems. And so they come up with this idea that dopamine agonist may be a better alternative. And so for a number of years, dopamine agonist that was the main reason why we were using more and more dopamine agonists, because probably because they have a different stimulation profile, we could get less levodopa-induced dyskinesias. But then you fix one problem, you create another problem. And that's basically how it happens with drugs, right? So that was the problem. So we learned that you can create also behavioral problems, but maybe having less dyskinesias. Yep.
Could you comment on progressive supranuclear palsy? We can give this you now for the next question. And I thought it's rare as one was like.
Right. Progressive supranuclear palsy, very important disease. Okay, as you know, this is what we call atypical Parkinsonism, okay, because it's a more aggressive form of Parkinson and does not respond as well to medication as Parkinson disease does, right? So we know that there is a lot of research now in this field of PSP, okay, because as you probably heard that PSP is associated with a protein in the brain is called tau, okay, which is different from the one that produces Parkinson, which is alpha-synuclein. And now there are clinical trials for tau that are undergoing in different parts of the world, and there is a lot of promises for this. So we'll see in the next 5 to 10 years what is going to be the outcome of these clinical trials, because that's our major hope, the word that she used, for this disease that is very debilitating for the patients, much more aggressive than Parkinson's disease.
Can you track declines in cognitive functions using brain scans?
Yes, that's the easy question. Yes, you can, definitely. Because now we have more and more of these fancy images, we can track the changes. Now, remember, there are different forms of cognitive declines. It's not only one form. So I won't go deep into the specifics, but there are forms that we call executive functions, more associated with the front of the brain, the anterior part of the brain, and those we know that are linked more with the dopamine. But then we have other problems that are more like memory problems, that is more with the back of the brain, the parietal lobe, the temporal lobe. And we know that is associated more with acetylcholine, amyloid deposition. So Those two are very different type of cognitive decline that we discover using these tracers, okay? And we know that the progression, the prognosis is quite different, whether you have an executive dysfunction or more what we call amnestic type of cognitive decline. So it's actually, we can do that now, yes. True. Hopefully they will ask you a question.
Okay, so now you have a better image of, like, you can see a decline or the evolution, and I feel like saying, and then what?
Right, that's a good. I mean, it's actually, then what? Our hope, you know what it is, our hope is that we can use this to measure, for example, to quantify the outcome of clinical trials, right? Because first, okay, so let's say if we have a very good biomarker, because that's our hope, to have a very good biomarker, first we can measure how effective is a treatment. But if we have a very sensitive biomarker, and that's all the research that is going on now, is how early we can discover these changes in the brain before the symptoms appear, right? So that actually is our mission, to find very sensitive, specific biomarkers in order to identify changes in the brain that happens before the patient starts experiencing the symptoms. Because then if you identify those, then you can act very early let's say with these clinical trials, and then maybe have an impact on the brain, okay? Because if you identify these things late, when these things are just already, when the patient has already lots of symptoms, maybe the medication is not as effective as starting before the motor symptoms or the symptoms manifest, because the brain has basically already degenerated or not, okay? Not necessarily medication, it can be anything, right? We don't know yet. We don't know, it can be something else, not necessarily medication. Yeah.
Is there an increase in MSA in the last few years?
I don't know if it's an increase let's say, an increase in MSA in terms of frequency, but I would say probably that we're become more sensitive in making diagnosis, right? So let's say before, probably we used to call everything Parkinson, because everything looks like Parkinson, right? But then as we get more sophisticated with things, then we start dissecting. This looks like more MSA, this looks like more PSP, this looks like more real Parkinson. So I don't think it's an increase in frequency. I think it's just that we're becoming more experienced. That's what it is.
So I'm Susan Fox, I'm the Associate Director, and I have spoken at this series a couple of years ago, and we all take it in turns, and it's a great experience. So it's my job to thank the speakers, Dr. Antonio Strafella and Elinor Johnstone, and thank you very much for a wonderful reading from your book, and hopefully people will, there are copies here for people to buy. Yeah, okay, great. So please come and have a look. I'd like to particularly thank Fraser Beryl for supporting this event. This is extremely important for our unit. We enjoy exchanging ideas, telling you what we're doing, and you can ask us difficult questions to challenge us and make us try and answer the questions for you. That's obviously what we're here for. Stephanie from the foundation will be sending out a video link later on sometime in the next few weeks from the recording of this event, so you can share it with your friends and family who couldn't come to the event. So please do that. The next event will be advertised and will be at some point later in the year. So hopefully you can all come and attend that as well. So I'd like to draw it to a close, and again, thank you all for coming, and hopefully see you all again. Thank you.